Okay, let's go over these practice problems. The first one says, which characteristic of a light wave remains constant when the light wave travels from air into corn oil? So this one's kind of memorization. When you travel into a new medium, the frequency remains the same. But they also gave a choice here of period. And remember that period is equal to 1 over the frequency. So if the frequency is remaining the same, so is the period. In this next one, they say the speed of a light ray, they give you the frequency, in corn oil is what? So corn oil, we can look up on the reference table, and corn oil is 1.47. So we put 1.47 in for our index of refraction. C is a constant, the speed of light in a vacuum. Cross multiply, and we get our speed in corn oil. In this one, we have a light ray that is incident on an interface, that just means a surface, between glass and air. When the light strikes the glass-air interface, some of the light is reflected. On the diagram in your answer booklet, use a protractor and straight edge to construct the reflected ray. So to do that, we know that the reflected ray has to be equal to the incident ray. So we use our protractor to measure out this ray. We measure from the normal to the ray, and then just draw a straight line using a straight edge. This says a monochromatic ray of light, mono meaning one color of this particular frequency, that happens to be yellow, travels from air into medium X. So it's going from n equals 1 into a medium that we don't know the index of refraction of. The angle of incidence, that's going to be our theta 1, is 45, and the angle of refraction is 29 degrees. Find the index of refraction of medium X. So that's Snell's law. Remember, your calculator needs to be in degrees. And n1 sine theta 1 equals n2 sine theta 2. Air, our first medium, is 1. The angle of incidence is 45. Here's our unknown material, and sine of 29 is going to be our angle of refraction. So we just do the algebra and solve for n2. In this question, they are looking for the angle of reflection. Well, the angle of incidence is from the normal to the ray, that's 60, and the angle of reflection has to be the same. So we know that this is 60 degrees on the way out. This one says, which waves require a material medium for transmission? In other words, what requires something for them to travel through? Now we know that transverse waves like electromagnetic waves can travel in a vacuum. So these are all electromagnetic waves. They can all travel in a vacuum. But sound waves require a medium. Which type of oscillation would most likely produce an electromagnetic wave? Well, electromagnetic, if we take a charged particle, it could be a proton, but if we take an electron and we oscillate it up and down, that's going to create an electric field that oscillates and a magnetic field that oscillates. So what is that? An electron traveling back and forth in a wire. If a monochromatic light ray, okay, so monochromatic, one color, passes from water into air with an angle of incidence of 35, which characteristic of light will remain the same? This question comes up a bunch, and this is kind of a memorization. You have to remember that when you change mediums, the velocity and wavelength change, but the frequency remains constant. Number 9, the absolute index of refraction of medium Y is twice as great as the absolute index of refraction of medium X. So this is a little tricky. As a light ray travels from medium X into medium Y, the speed of the light ray is what? Well, we can do n equals c over v, and if we're going to double n, then how do we get a doubling of n? Well, we get a doubling of n by cutting v in half. Remember that if we multiply through by v over 2, that's going to be the same as multiplying that by 2, like that. So the answer is it gets cut in half. This one is actually from Waves Part 1. The diagram shows a transverse wave moving to the right. At point P, that's supposed to be like that, point P on the rope is moving towards what? Well, remember when we did that diagram or that video of the waves, if the waves are moving this way, the beach is over here. So this could be like a surfer that's on the front edge of the wave. Which way is the wave pushing them? The wave is pushing them up.